Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. Okay, my name is Dr. Amjad Shameen, and in this lecture, I will be talking about fundamentals of hypothesis testing, one sample test. In this lecture, you will learn the basic principles of hypothesis testing and how to use hypothesis testing to test a mean, and also to identify the assumptions of each hypothesis testing procedure, how to calculate them, and the consequences if they are seriously violated. The first important point is to understand what is a hypothesis. Okay, so the hypothesis is a claim or assertion about a population parameter. A population parameter, okay, what is that and how to write a hypothesis? For example, the mean monthly cell phone bill in this city is $42. This is what you have claimed. So you will be writing a population parameter which is denoted by mu is equal to $42. Now you want to test whether this is true or not true. Okay, so that is what you have hypothesized, and you want to test whether it is what you have claimed is correct or is not correct. Now, there are two types of hypothesis. One is called null hypothesis and the other is alternative hypothesis. The null hypothesis is always denoted with H naught. Okay? It states the claim or assumption to be tested. Let's take another example. You predicted or you claim that the mean diameter of a manufactured bolt is 30 mm. So how are you going to convert this statement into a hypothesis? Null hypothesis H naught colon mu, which is a population parameter, is equal to 30. Now, you want to know whether this is true or not true. Remember that when you're writing a hypothesis, you always need to write a population parameter, which is denoted with mu. You cannot write it with x bar, which is a sample statistic. Okay. Now, when you want to know about this specific statement, whether true or not true, right, you have to test it and you have to collect data and you have to use appropriate analysis technique to prove about this assumption. We will learn that one in a while. Before that one, I want to highlight few important things. When you're writing a null hypothesis, remember you can use any of these three signs. Either you can use is equal to, or is equal to, less than or equal to, okay, or greater than or equal to. You cannot use is not equal to for the null hypothesis. Okay, and remember that the alternative of the null hypothesis is called alternative hypothesis. This is denoted with H1 or H2 if you have more than one hypothesis. So this is just the opposite of null hypothesis. In our earlier example, when you said the mean diameter of a manufactured boat is 30 mm, just make a reverse and you will write the mean diameter of a manufactured boat is not equal to 30 mm. And you will need to write H1 mu is not equal to 30. Remember that you can never write alternative hypothesis with any of these signs. For example, is equal to, less than equal to, or greater than or equal to. You cannot write this one for the alternative hypothesis. Any of these signs are always used for the null hypothesis, and the opposite it is not equal to. For example, if you're using is less than or equal to for this one, so then it means that if it is not less, of course your hypothesis is not accepted, right? So your alternative hypothesis is not equal to 30. Okay. Now remember that if we take another example, population mean age is 50. So you're writing null hypothesis H naught mu is equal to 50, and its alternative hypothesis will be mu is not equal to 50. Sample the population and find the sample mean. Suppose sample mean is x bar, which is denoted always with x bar is equal to 20. So we have sampled it and we want to know what is the sample mean. So this is the population mean, and we find sample mean is 20. Okay, this is significantly lower than the claimed mean population age of 50. Remember, just now you said mu is equal to 50 and you found x bar sample mean is equal to 20. So there is a very big difference between 50 and 20. Okay. Now, if the null hypothesis were true, what we predicted, if that was true, the probability of getting such a different sample mean would be very small. So you need to reject the null hypothesis. In other words, getting a sample mean of 20, as you can see here, is so unlikely if the population mean was 50. Okay, so you conclude that the population mean is not equal to 50. That's why your alternative hypothesis is accepted. Null hypothesis is not accepted because you predicted it is equal to 50, but you found is equal to 20. Okay. Remember, we have discussed about the normal distribution curve. Okay. And we have said that your data is normally distributed if you get this kind of graph. The same kind of visualization can be used in the hypothesis testing. Remember what we said? Here is the mean, which is a central point, and on the right side and the left side is the distribution of the data and deviation from the mean. Okay, we talk about the standard deviation. Let's say if mu, what we predicted, is equal to 50, if h naught is true, then it should be 50, right? When in fact this was the population mean. But now we are talking about the sample mean. What we found sample mean is 20. And you can see 20 is significantly different from the 50, which is on the left side over here. Then what you need to do, you just need to reject your assumption that what you predicted is not true. Okay. Test statistic and critical values. Very, very important to know when to reject the null hypothesis. If the sample mean is close to the stated population mean, the null hypothesis is not rejected. In our case, the sample mean is not close because 50 and 20 is significantly different. Of course, we have to reject the null hypothesis. But if the sample mean is far from the stated population, then in our situation just now we have given example, we have to reject null hypothesis. Okay. But interesting point and interesting question is, how far is far enough to reject null hypothesis? What do we mean by far? Is 1 digit is far, 2 digit is far, 10 digit is far, 20 digit is far, 50 digit is far, right? Of course, far can be how far? Question, right? So the critical value of a test statistic create a line in the sand for your decision making. Okay, it answers the question of how far is far enough. So question, what is critical value? Do you know what is critical value? Of course, we have to find out. We have to know what is critical value. Only then we will be able to decide how far is far enough. So in order to know about our critical value, we have to understand some more things. Too far away from mean of sampling distribution, or very far, a little bit far. Remember again the same visualization when I discussed earlier in the class, and you can see over here in this region, this is called acceptance region or region of non-rejection. You cannot reject anything over here. And these two are called region of rejection. If your values fall in this region, either here or here, of course you have to reject it. Okay, but if your values far closer to the mean, if standard deviation is not so far, you cannot reject null hypothesis. But very important point for you to understand, sometime in hypothesis testing you may encounter error, and there are two possibilities of having error: type 1 error and type 2 error. We need to understand very clearly what is type 1 error and what is type 2 error. Okay, remember, type 1 error is when you reject a true null hypothesis. True null hypothesis should be accepted. If you rejected it, you encounter type 1 error. And this is a false alarm. It's not a right decision. And probability of type 1 error is denoted with alpha, called level of significance of the test, and this is set by the researcher in advance. Remember, earlier we mentioned alpha can be 0.05, it can be 0.01 if 90% confidence level, 99% confidence level, and it can be 0.10 if you are setting a 90% confidence level. So as a researcher, you choose you are taking at 95%, 90% or 99%. Then your alpha is already known. Okay. True null hypothesis, no need to reject, otherwise you are encountering type 1 error. Number 2, if you fail to reject a false null hypothesis, you are encountering a type 2 error. Meaning a false null hypothesis should be rejected, but you fail to reject it, you are encountering a type 2 error. And is a missed opportunity. You have missed the opportunity to accept a very nice hypothesis, but you missed it. And the probability of type 2 error is denoted with beta. Now, possible error, if we plot in a contingency table, this is how it looks like and very easy to understand. Let me explain a bit more. Just take two decisions in hypothesis testing that we always have. Either to reject H0 or do not reject H0. Remember, H0 mu is equal to 50. Opposite is alternative hypothesis. The moment you rejected H0, opposite alternative hypothesis is already accepted, right? So we are talking about null hypothesis, and you can also imagine about the alternative hypothesis decision, because that is opposite, right? Now, decision 1, if do not reject at null hypothesis, if it is true, then you have made a very correct decision, which is correct decision, true, H0, do not reject it. But if H0 is true and you have rejected it, you encounter type 1 error. And type 1 error is alpha. This is denoted, confidence is 1 minus alpha. Remember these two, later we will need it. The second situation, if in case your H0 is false, if it is false, what you need to do? Of course, you have to reject it. And if you have done so, you are making a correct decision. But if it is false and you are still accepting it, you are not rejecting it, you are encountering type 2 error. We denote it with beta. You see, 1 minus alpha for correct decision, 1 minus beta is power. This one is confidence, this one is power. It is denoted with 1 minus beta, is also a correct decision. But if false and you do not reject it, encountering type 2 error and denote with beta. Now, the confidence coefficient 1 minus alpha is the probability of not rejecting H0 when it is true. And confidence level is of hypothesis is 1 minus alpha multiplied by 100%. You can find it out, the confidence level. And the power of statistical test, which just now I mentioned 1 minus beta, is the probability of rejecting H0 when it is false. And when it is false, it should be rejected. If you are not rejecting, you are making a wrong decision. What is the relationship between type 1 error and type 2 error? It's very, very important. Type 1 and 2 errors cannot happen at the same time, must remember. Okay, type 1 error can only occur if H naught is true, and type 2 error can occur if H naught is false. If type 1 error probability is high, then type 2 error probability is low. So the more is the alpha, the lower is the beta in this case. Okay, all else equal. If beta is high, when the difference between hypothesis parameter and its true value is low. When beta is high, when alpha is low. Or when beta is high, sigma is high. Or when beta is high and size of the sample is low. Some of the factors, these kind of factors can cause type 2 error. Okay, so when you encounter type 2 error, then you find out whether the problem is because of alpha, because of sigma, standard deviation, or because of the sample size. Then probably you manage to find out all those problems, and hence you can figure out how to correct your decision. Now, very, very important to know about the decision making. Okay, so the level of significance that can help us to identify the rejection region, and hence we can go for the decision making. Remember our example, mu is equal to 30. Alternative hypothesis, mu is not equal to 30. And level of significance we talk about is alpha. This is alpha. Sorry, this is the mu, population mean, which is 30. And this is the alpha by 2. Half is on the one side and half is on the other side, because this is two-tailed test distributed on both positive and negative sides. If it is on one side only, no need of alpha by 2. It's only alpha. Okay, because we are taking two-tailed test, so of course this is alpha by 2, half here, half here. This is the critical acceptance region, and here are the critical values. Any value, if falling over here, this is very far from 30. Okay, and then of course we have no choice but to reject our null hypothesis. Now question is how to find this critical value. This is a very critical question. Remember, we talk about testing hypothesis for the mean is population mean denoted with mu. In order to calculate mu, we have two conditions. One is when sigma is known. What is sigma? Standard deviation. And the other condition is when sigma is unknown. Why we need sigma? Because we need to see the deviation from the mean and what is the critical value that can help us to make the decision whether our hypothesis is true or not true. Now, in order to know this mean, we need sigma. And if sigma is known, we can use z-test to calculate the critical values. Okay, but if sigma is not known, then we can use t-test to calculate the critical values. In this lecture, I'm only focusing on when sigma is known. Okay, convert sample statistic x bar to a z-stat test statistic if you have this sigma known. Then you will be able to make immediate decision about your acceptance or rejection of the null hypothesis. Because your formula says z-stat is equal to x bar, if it is you have already, and mu, which is of course your hypothesis prediction. And as I said, if sigma is known and sample size is known, you just put it x bar minus mu divided by sigma over n square root, and you will get the value of z-stat. And this is for two-tailed test for the mean when sigma is known. Okay. Now, what will happen? You just need to get the critical z value for a specified level of significance alpha from a table or by using computer software. So I will suggest you just Google and you will find out z value. Predetermined z values are already available in a given table. You can find it out in any statistics books or even on Google in different websites. Decision rule: if the test statistics falls in the rejection region, reject H0, otherwise do not reject H0. That is our decision rule. Okay. Now there are two cutoff values defining the regions of rejection. Okay, you have seen over here we mentioned 30. If your value fall here, do not reject H0. If it falls over here, reject H0. This is called upper critical value and this is called lower critical value because sign is negative. Here the sign is positive. Remember, there are 6 steps that we need to use in order to test hypothesis. Number 1, state the null hypothesis H0 and the alternative hypothesis H1. Number 2, choose the level of significance alpha and sample size. And alpha, as I said, can be 0.05, 0.01, 0.10. It's your choice. But this choice should be logical, okay? The level of significance is based on the relative importance of type 1 and type 2 error in the situation. Number 3, once you know your hypothesis, once you know your level of significance, now you can determine the appropriate test statistic and sampling distribution. Okay. Number 4, determine the critical values that divide the rejection and non-rejection region. Once you know about that, then you collect data, organize the results, compute the value of test statistic, and then number 6, you make the decision. Okay, determine whether the assumptions are valid and state the managerial conclusion in the context of theory, claim, or assertion being tested. If the test statistics fall within non-rejection region, do not reject null hypothesis. But if the test statistics fall outside of the acceptance region, is fall in the rejection region, you have to reject the null hypothesis. Once you reject the null hypothesis, you accept the alternative hypothesis, which is the opposite. For example, let me put all this what I said into a practical example to show you how we have decided to accept or not to accept the hypothesis, null hypothesis. Okay, let's say we want to test the claim that the true mean diameter of a manufactured bolt is 30 mm and our sigma is known, which is 0.8. Now, when sigma is known, immediately we will know, okay, we have to use z-test. Let's put this one into 5 to 6 steps. Number 1, state the null hypothesis and alternative hypothesis. So here we stated mu is equal to 30 is our null hypothesis and H1, mu is not equal to 30 is our alternative hypothesis. Step number 2, specify the desired level of significance and the sample size. Let's say I'm choosing 0.05 as alpha value and our sample is 100. Okay. Number 3, sigma is assumed known, as just now I mentioned. Here it is 0.80, so I will be using the z-test. Technique that we are going to use is z-test. Okay. Number 4, determine the critical values. Now, from the given table at 0.05 alpha value, you can find it out. It is standard predetermined value for z, which is plus minus 1.96. As I said, predetermined, so you can find it out in the table. Number 5, collect the data and compute the test statistic. Suppose we have already collected a data from a sample and our sample is 100 and our mean, sample mean. So once we collect data from 100, of course we can easily calculate sample mean, that is x bar. And let's say when we calculated and we found x bar is equal to 29.84. So luckily now we have x bar, we have mu, we have sigma, we have n. Of course we can easily calculate z state, the z value. So just put into the equation that just now I have shown to you and you will find it out. The z state value is minus 2.0. Last step in decision making, whether this value is within the acceptance range or is outside of the acceptance range. Remember, minus 2.0 is less than minus 1.96. And if we plot here, you will find it out, this is falling over here. It is more towards the extreme left. So when this minus 2.0 is falling less than minus 1.96, which is in the rejection region, so immediately we can make the decision. Our null hypothesis, which is mu is equal to 30, rejected, is not equal to 30. Hence, alternative hypothesis is accepted. Our null hypothesis is rejected because we wanted to see if that value falls over here, the z stat. But here z stat is out of the acceptance region. It is in the rejection region. So therefore, of course, we have to reject our null hypothesis. Okay. So conclusion, since z stat is equal to minus 2.0 is less than minus 1.96, hence we reject the null hypothesis and conclude that there is sufficient evidence that the mean diameter of a manufactured bolt is not equal to 30. Remember, if it is equal to 30, of course, what we predicted, we found the same. You can see generally there is a very minimal difference. 30 and 29.84, a minimal difference. But despite of the minimal difference in some sort of decision making, this difference is huge. That's why you can see the implication is huge. Our hypothesis is not accepted. In terms of diameter, bolt, right? So of course, when you have to place a 30 mm bolt, there you cannot place 29.84 volt, right? So that is what the true finding that you got. So hence your null hypothesis is rejected. Now, in addition to just deciding based on the z value and comparing with it with the alpha value, and another approach is also a p value. P is a probability value. Okay, so the probability of obtaining a test statistic equal to or more extreme than the observed sample value given H0 is true. And p value is also called the observed value of significance, and it is the smallest value of alpha for which H0 can be rejected. Let's say compare the p value with alpha, and alpha is 0.05. And if we found p value less than 0.05, of course we have to reject null hypothesis and we have to accept alternative hypothesis. Remember, if the p value is low, then H0 must go. Okay, so therefore getting p value less than 0.05 is the one that can help us to decide about our null hypothesis acceptance or rejection. So if we want to use this 5-step approach for p value, okay, so what we need to do, we have to use the same. Number 1, state hypothesis, null, alternative and null hypothesis. Number 2, choose the level of significance and sample size. Number 3, choose the statistic, which one is going to use and which one will be the sampling distribution. Collect data and compute the value of test statistic and p value. Now here this is addition, p value, because now we said how we can use p value to make the decision. And of course make the statistical decision about the acceptance or rejection of the null hypothesis. So all steps same. You can see here mu is equal to 30. Second step also, alpha is 0.05 and n is equal to 100. Determine, and we know about our sigma, which is 0.8. Number 4, here is the addition. We have to calculate the p value, and you already know about our z stat, which is minus 2.0. So let's say if we can find it out, our z, which is greater than 2, because it is a two-tailed, so we divide alpha by 2, 0.0228 here and 0.0228 here. And if you add these two values, you will find it out 0.0456. And actually, this is the p-value. This is the p-value. Okay, so you just need to add this rejection region. You remember alpha by 2 we mentioned, and here you find it out the values. You just add, you find out p-value. Now compare this p-value. So you can see, is the p-value less than alpha? Since p-value is equal to 0.0456, which is less than 0.05, hence you have to reject null hypothesis. Okay, as you can see, it is 0.04, which is less than 0.05. Hence we have to reject null hypothesis and we have to accept the alternative hypothesis. So this states the managerial conclusion in the context of situation. Decision: there is a sufficient evidence to conclude that the mean diameter of a manufactured bolt is not equal to 30. Okay, that is what we have decided, because our p-value is less than our alpha. Okay, so that is how we can use hypothesis testing to make the decision. In conclusion, what we have learned about the basic principles of hypothesis testing. We have learned how to use hypothesis testing to test a mean, and also what are the assumptions or steps of each hypothesis testing procedure, and how to calculate them, and how to make the decision. Thank you.